Now, I am told, according to my tweets, I was just checking Twitter, it says here that the very dedicated Thad Starner is going to present here in a moment about he's been wearing a customized, according to the tweet, he's been wearing a customized computer continuously since 1993. And I'd like to call Thad up to the stage to present to us now. Thank you very much.
So I'm told I have 25 minutes, so I'll try to keep it to that, especially since I have a clock on my screen. So hopefully I can be pretty good about that. Wearable computing is basically about computers that are worn like clothing, that allow you to do computation and communication while you're having everyday interactions. And the idea is actually pretty old. A guy by the name of Claude Shannon and Ed Thorpe made one back in the 1960s for predicting roulette. And they actually made some money off of Las Vegas this way. Now, you might have heard those names before. Claude Shannon is the guy who gave us the term baud rate. Or bits per second. He's the father of information theory. Ed Thorpe, you may have also heard of if you are a gambler. He's the one who wrote the book, How to Beat the Dealer. In other words, he was a probability professor at MIT and showed how you can count cards. He also did this little thing called a hedge fund, which I guess may not make him so popular right now. But so these ideas actually were around before I was born. What my claim to fame is I'm the first person to use a wearable as an intelligent assistant in my everyday life. And I've been doing so since 1993. Now, along the way, I've convinced a lot of people at MIT and Georgia Tech and at ETH in Switzerland, Bremen, and a few other places to actually live this lifestyle with me. And wearable computers is more about a lifestyle than anything else. And what we're trying to do is we're trying to create a community of people who use the technology we see coming for your everyday life and see where it leads, and may be able to sort of guide where the technology goes. Now, in the past 20 years, a lot of the ideas that we prototyped have come out. There's a lot of niche applications out there, as well as stuff that you're familiar with in your everyday life. Niche applications include things like inventory control. The image up at the top right there is from Symbol Technologies, and this is a device they use in FedEx or UPS or big global mail delivery systems, so that when their workers are reaching into their big crate of packages, they reach in, trigger the barcode scanner, grab the package, and put it on the right conveyor belt. And it turns out that that little thing there is worth many, many millions of dollars and allowed Symbol to differentiate themselves from other vendors for this huge market on inventory control. There's also a lot of work in inspection, maintenance, and repair, and also in the medical field, things like implantables. They now have a system for Parkinson's disease, this is a wearable system, where there's an electrode that goes down into your motor cortex. It gives you sort of like a brain pacemaker that actually alleviates a lot of these symptoms you see in Parkinson's. For example, if you ever see a pill-rolling tremor, something that looks like this when somebody has Parkinson's, Michael J. Fox is a celebrity that you might have seen with this tremor. When you turn this thing on, suddenly they're like this. It's quite shocking. Unfortunately, the effect goes away after a few years, and we're doing a little work on that, trying to improve it. But these niche applications is not what I'm really excited about. What I'm excited about is how wearable computing is affecting the world. In 1996, we made a mobile computer about the size of 2 decks of cards put together. And we used that with a standard we were working on at the time called MP3. And we created a music player that could actually change the songs based off your mood. We used galvanic skin response, heartbeat, blood pressure, a few other things. And the system tried to guess what mood you're in and then change the song appropriately. We showed this to one of our sponsors. Their name was Sony. And they said, oh, we don't want that. We're like, well, why not? Well, we just bought Columbia Records, and having a digital form of our songs on a mobile device like this, an MP3, would encourage too much piracy. Of course, now, Apple is the new Sony. Interestingly enough, Apple was a sponsor at the time, but I don't think they got the idea from us. I've never asked, but one of the other things that came out of the wearable computing community is there was a big push for a body wireless standard. Now, this push came from FedEx. I gave a demonstration to FedEx, I think, in 1995, FedEx being the big American mail delivery service. They looked at my equipment, which was pretty similar to what you're seeing right now, actually. It's an older system. And they thought that this guy, Thad Starner, was completely nuts. And then they came back the next month and said, we want to equip every carrier in our fleet, every person who drives a truck in our fleet with a wearable computer. And we're going to spend $100 million next year to do it. I'm sitting here with my jaw on the floor going, you're nuts. You're, kind of flipped the other way now. Why would you want to do that? Well, because we want our mail delivery people, our carriers, not to be package movers. They are customer relationship managers. We want to automate the package flow so much that they can actually shake hands, get a personal rapport with the people they're working with, and actually represent our company. And they said, well, what? I said, well, that's great. I understand now why you want to do it, but you still can't do it. The technology is not there. What do you need for the technology? I mean, you're doing it. It's like, well, what you really want to do is get rid of these wires. And for that, you really need something called BodyNet, or this personal area network we're working on. But it's really got to be an industry standard. And so FedEx, in particular, a guy by the name of Dick Braley, set out to make something called 802.15, which you guys now know as Bluetooth. Fortunately, Ericsson, who was also another one of the sponsors visiting at the time, had something cooking up in their labs and brought it out in a rush order for us so that we'd actually have it ready for the standard. We've seen other stuff come out of the community, including things like instant messaging on mobile phones. We called it the Zephyr in the 90s, early 90s. We also did something called augmented reality. Now, we coined the term augmented reality to sort of convey to people what it was we wanted to do. And let me show you something from '96 that actually shows that. The idea is that we could actually have a system where we move the World Wide Web to the real world. Everywhere you look, there might be tags. These days they're called QR codes that show you hidden content on the physical world. And that content basically just hooks back up to the World Wide Web. These days, you don't need the tags. And you can actually do 3D alignment. You see this is kind of 2.5D. But you can actually do 3D alignment with these things. We'll see another example of this in a second. And remember, this is 1996. Now, what's cool about all this is you no longer need really high-end equipment to do this. One of the professors at Georgia Tech, this guy here, by name of Blair McIntyre, has got a lot of this stuff working on mobile phones. And he's been doing augmented reality as drama. Right? He's put you into movies or plays with your cell phone or into Second Life. And he's actually showing how you might use this augmented reality to extend media as we know it. So what's really great is that we've had a lot of people take the ideas we had from the wearable computing community and run with them, and it's been wonderful to see all this stuff happen. But I think a lot of the lessons we learned have been lost. I have a video to show what I mean about that. Let me actually make sure my audio is on here.
BlackBerry from RIM Systems. Text, web, email, power in the palm of your hand for the professional on the go. And introducing the BlackBerry Helmet, reinforced polymer to protect the skull of the mobile professional on the go, with an antenna for better BlackBerry reception so you can spend more time on your BlackBerry. And a camera that broadcasts a picture of what's in front of you to your BlackBerry so you can always be looking at your BlackBerry. The BlackBerry Helmet with optional safety flag. Protect your skull while you destroy your thumb.
What I love about that is I didn't have to make it. Some comedians at the CBC did, the Rick Mercer report. But it kind of shows that people, the community is now becoming aware that these devices are replacing our lives. With a BlackBerry, you can see people walking down the street completely absorbed in the keyboard and screen that they have. And they're forgetting to live, right? We're trying to make devices here that augment your life, that make your life calmer, that actually helps manage your interruptions instead of creating more of them, that creates systems that are part of your life, that augment your experience, not replace your experience in the real world. And so let me get to what I've been using for this. One is heads-up displays. Now, this is a system that we've been trying to make so that you can use it while in face-to-face conversation. You can use it right now, for example. You can use it just about any time. Now, the system, this is from 1997. This is by a company called Micro-Optical. And there's a display actually in the earpiece here that hits a small mirror in the corner of the lens, goes through the lens, whoops, oh, that was useful. Goes through the lens, and, well, we're going to have one of those days. And then hits the mirror and goes into your eyeball. Now, you might say, why aren't I wearing this now? Well, that one was 320 by 240 monochrome, and it was relatively fragile. It was a prototype. It was the first prototype of its type. I've since switched to the other images that you can so greatly see on the slide, where it actually clips onto your glasses. And I have that sitting there. People want to see that later. That is, I think, the best system out there currently, or was out there until the company made an incorrect bet. These displays, I think, are actually getting to the stage where they're actually very usable. Now, people often ask, this is going to be fun. Ah, there we go. So that's the display here that I was talking about. Oh, let me go back. Well, we'll go on to the next idea. So people often wonder, well, Thad, you're trying to make systems where people aren't looking at displays all the time. But how can you see anything with that opaque display in front of your eyeball? Right? Seems like that's counter to what you're doing. Well, let me give you a demonstration of this. So hold up your thumbs and close one eye and pull your thumb back towards your head, and then line up your thumb on top of my face. Everybody got it? So once you do that, then open the other eye, and you'll notice that you can kind of see through your thumb to my face. Right? Close the eye again, you see you're blocking out. Open the eye, you can see through it, which is really kind of excellent example. Yeah, so now whenever I do this, I actually take pictures so my dean knows that I'm doing a good job. So thank you very much for that. So what you get is basically the equivalent of an illusion here. So here's kind of a representation of that. You can see that this is my text buffer that I have here, and that my system is overloading some information on the conversation while I'm talking to this guy. This guy is a reporter from 48 Hours. So while they're filming me, I'm filming them. But this kind of shows you what the illusion looks like. Even though the display is a peg, there's optics there that bring it into focus, so that while your thumbs are out of focus, my display is perfectly in focus while I look at you. Okay, going forward. So one of the other parts of this is making a keyboard. Now, the keyboard I use is something called the Twiddler. It's a one-handed device. It allows me to type up to 130 words per minute, right? So that's more than most of you probably type on desktop keyboards, unless you're a programmer. Now, how it works is really quite simple. I have my 4 fingers here. They map to the 4 rows of keys. And you can see that it's A, B, C, D, E, F, G, H, just as shown on the diagram. And then there's a red dot over here on the space. So you hold down the space key, and you hit the B key at the same time to get the I. Then it's J, K, L, M, N, O, P, Q. You switch over to the blue shift, which is the E key, then it's R, S, T, U, V, W, X, Y, Z. So you can learn this keyboard in 5 minutes. You can touch typing in 20 minutes. You get to about 30 words per minute in 6 hours of practice, reading your email, that sort of thing. In most, I think the average person gets around 50 words per minute, which is equivalent to most people's desktop typing rates. Matter of fact, 50 words per minute is the highest pay grade in the US government for typing, or it used to be. So what's great about this device is that you can use it without visual attention. You can use it in face-to-face communication. Right? You can basically use this keyboard almost anywhere. Now, the computer itself has been shrinking quite a bit. The computer I'm wearing right now is a laptop given to me by Google that I'm wearing for security purposes. But the machines that I make myself tend to be much smaller. We started out with these systems here, which were quite big, kind of fit around your hip. These days, however, what my students have in the lab is something about the size of a stick of gum. And you can stick a 32 gigabyte SD card in it. Actually, these days, it would be a micro SD. So you end up with something about the size of a stick of gum. Unfortunately, the entire device is about the size of a pack of gum because you still got to have a battery. Right? And that battery is what takes up a lot of space. But we can make the computers disappear. Now, making the computers disappear is actually the easy part. Right now, mobile phones, probably some of the mobile phones in your pockets, are actually as powerful as the Cray XMP supercomputer that was the hot machine to have back when I first started my career. The problem is not going to make these machines shrink down. The problem is the interfaces. There's only so small we can make keyboards for our fingers. There's only so much attention we have to spend spend between the virtual and the real world. So we really need to concentrate on making systems that are usable while walking, working, and socializing. We've got to avoid this BlackBerry helmet experience. So now that you have some background of what the equipment is I'm wearing, one of the things people always ask me is, why did I do this? Well, back in the 1980s, I was spending $20,000 a year on an MIT education. You know, back then, that was a heck of a lot of money. I guess it's now about $45,000 a year. And I realized that I wasn't getting much from it. I would go into a lecture, I'd pay attention, and I found I could either take good notes or pay attention, but not both. If I paid attention, I would understand the concepts for all of 2 hours, then I'd walk away and promptly forget it. If I took good notes, I could retain the notes, but I'd never get an intuition, so it was useless to me. So I made a system that used the heads-up to screen where I can put the focus of my screen at the blackboard. I don't have to look up and down all the time. I made a keyboard, or I got a keyboard that was fast enough to type notes very quickly, so I could do very complex mathematics with this keyboard and actually keep up with the lecturer. But what I found that was really compelling is that my education at MIT was not in the classroom. It was in the hallway conversations. The things that were most relevant to my life and to my career were talking to a professor over the water cooler or walking past a grad student on the way to the bathroom. And I had no way to retain that information. You know, here's a simple example. Trevor, how do I get my information off of backup tape? Oh, Thad, it's easy. It's xvf/dev/nrst11. That's actually the command. And of course, by the time I walked back to my computer, I completely lost that information. With this computer, I can get right there as I'm talking to the person. So that's why I did this. And then there was science fiction authors tend to pester me at conferences. And one of them, his name was Werner Vinge. Since this is an education conference, and the reason I did this was for education, for my own education, let me recommend a book to you. This is Rainbow's End by Werner Vinge. It won the Hugo and Nebula Awards in 2007, just like almost every other book that Werner writes. And what it does is it talks about what happens when you give school children, like the children next door, a wearable computer, augmented reality, and a social network. In other words, we have a wearable computer that helps them remember their experiences and also develop their lessons interactively with computer support as they're working on their project. Whereas we have augmented reality where every surface or even the air itself becomes a blackboard, a public blackboard where we can leave notes for other people. What happens when you can recruit other people to solve your class problems? Now, this is really exciting to me and really scary because what he says ends up happening is high schools end up being like think tanks where they spin off micro companies to sell their class projects. And after reading this book, which is much more articulate than I ever could be as a public speaker, it's a wonderful book. I have a lot of nits to pick with the technology, but I can't refute his education model. It's a bit scary, so I highly recommend you guys reading it, and if you have opinions about why this model could not happen or will not happen, I'd really like to hear it, because it really changes everything we're doing as far as education, at least at my level, and I think the whole way down to elementary school. Okay, now, if you notice that the talk abstract, or the talk title, I was talking about tactile systems, and unfortunately I don't have much time, so I'm just going to talk about one of these things called the Mobile Music Touch. Now this is a glove that can teach you how to play piano melodies without your active attention. Now, as educators, we often think that we need active attention to teach something. You know, the whole idea of learning Spanish in your sleep, yeah, it just doesn't really work. But it turns out learning piano while you're reading your email does work. Let me show you.
All right, in today's Big Eye segment, technology to help you learn to play music just by touch. It's TJ and the Pips here today. Researchers at Georgia Tech have developed a glove that connects to your cell phone, your MP3 player, or laptop. As the music plays, the tips of the glove vibrate on your fingers to correspond with the fingers you would use to play that song.
Yes.
Not just about learning to play music, though. It can also help be used as a rehabilitation device for people who have lost use of their hands. Technology going to be highlighted at a future Media Fest at Georgia Tech here in Atlanta next month. And Thad Varner, I have that right? Starner,
yes.
Associate Professor at Georgia Tech. I have Chad here because Chad has been practicing with this for the past hour or so we'll put it to the test here in a second. But initially, just explain what this is to lay people, if you will. We're trying to understand.
Well, if you're like me,
okay.
You would really like to learn to play a musical instrument like piano,
okay.
but you really don't have the time to do the practice. And wouldn't it be great if you could actually rehearse songs you want to learn without paying attention to them? Okay. And we've discovered this effect called passive haptic learning, where it seems like it's actually possible to do that. So we made this glove, we call it the Mobile Music Touch. And what it is a wireless device that hooks into your cell phone or laptop. Right. And so while you're reading email or watching a video or doing whatever you normally would do, the system plays the song you want to learn. In this case, we're doing Amazing Grace. And as each note is played, vibrators in the fingerless glove vibrate to tap the finger that corresponds to that note on the piano. So what's really amazing about this, in about a half an hour, you'll be able to learn sort of the muscle memory of how to play the song.
Wait a minute now. You're telling me all I got to do is put on a couple gloves and you play a song for me for a half hour or an hour, and I can go put on a concert somewhere.
Well, I'm not sure about a concert,
okay.
But you can certainly pick it out pretty much easily than you could before. And it seems to work not only just for learning a new song, but also for rehearsal. So, you know, if you're a musician and you have problems with repetitive stress injuries, you can actually have the gloves sort of give you that muscle memory, that feeling of the song, and then you concentrate on the expressiveness.
Now, is someone using this for that application yet? You all just developed this. It's not in use. Nobody's using it just yet. Is that right?
Well, we've done 4 studies on it, so we really know this effect works pretty well. And as you can see, the system is relatively small. You can run it off a normal cell phone with a Bluetooth connection. So we're not there yet. We're still in the laboratory. But one of the things that we've really got excited about is not just, you know, learning it for having people learn it for playing music, but also for rehabilitation. So let me introduce Major Tanya Marco here, this is her PhD work, and she's doing some work now on real
work. Yes, because a lot of people would love to be able to play instruments, but you're talking about other applications.
Yes, sir. What we're looking at is using it as a form of hand rehabilitation. So we're currently working with people who are designated as quadriplegics, which means due to a break in the neck, they've lost the ability to use the 4 limbs. What we've done is worked with a few folks, and they've tried the glove. One thing that's really neat about it is they get to play the piano, which is actually a form of rehab in and of itself because you're doing some fine, dexterous movements with the hand. But we've had some interesting comments about the vibration, that it tended to kind of remind them of where their fingers were, because many of these people have lost the ability to sense with their hands. So if they touch an object, they don't get that feedback of actually touching something. So we're trying to improve their ability to perceive with their hands, and also their ability to use their hands, those fine motor skills.
Okay, wow, that is amazing, an application there. I'm certainly amazed as well that you could put a glove on and 30 minutes later be able to play the song. Chad has had this glove on for how long now?
About 45 minutes.
About 45 minutes. What was the song?
Well, this is what the song would have sounded like.
Okay, that's the before.
That is my musical repertoire.
Okay.
That's how good I can do it.
So he's had the glove on for 45 minutes. And what was the song, by the way?
It's
Ode to Joy.
It's
Beethoven's Ode to Joy.
Oh, this ought to be good. All right, Ted.
Okay. This thing buzzed, and all I did was I played on my mouse.
Okay.
I did my little
You were doing
hurricane
other
stuff.
things.
Did my hurricane stuff, and it was buzzing on my fingers.
You were working.
Let's see if I can do it.
Oh, you gotta be kidding me. Are you kidding me? Now, do you have any talent, a background in music? Ever played the piano?
Okay, you get the idea. What's really funny about this guy is he's a meteorologist. So he's back at CNN's news desk tracking the hurricane, right? And we put the glove on him. And you can see he's really nervous when he comes out there, kind of not really believing this is going to work. And that's why he's so tentative at first. But I will say I've done exactly this song while giving a talk like this. I'll have the thing sitting there playing the song in my ear and tapping my fingers. And after the talk, I'll go and try this new song that I haven't played before. And it's like your hand is possessed. Like the muscle memory is there. I'm not saying anything about musicality or expressiveness, but the muscle memory is there, and suddenly it just works. It is really, really freaky. So the question is, what can we do with this? And that's one of the things we've been looking at. There's some experiments, but I'm out of time. If you don't believe me about this stuff, we've run about 5 experiments right now on this project, and I can give you lots and lots of data about it. We're talking about rehabilitation. One of the things that's been very exciting about all this is we've started to see with our quadriplegic participants that they are actually starting to get recovering of their dexterity. They'll improve their ability to grasp and release objects using standardized tests. Their ability to sense 2 points on their hands has improved. And their ability to do activities of daily living has improved, including buttoning their buttons. So with that, I'm going to wrap up, and I'll be around with my equipment so people can see it for themselves, and I'll take questions now, later? In a moment.
Actually, I have one question
Okay.
that's come from the Twitter space. They want to know, are you secretly, sneakily tweeting while you're talking to the people in the audience?
No, I am not very good at multitasking at all. So one of the things that I find is I multiplex my attention very quickly. So if you ever see me, typing furiously while talking to you, it's because you said something interesting, and I'm trying to get it down. All right. It's very easy to tell when I'm doing email or doing something else, because my IQ goes down by about 40 points. You can see my eyes go back and forth as I read. Matter of fact, if you were observant during this talk, I have a couple of transition sentences on my screen, places where I failed in practice, to actually help me give a better talk. Okay, thank you very much.